Hey, good morning, everyone. A warm welcome to all the participants joining us today. Myself, Vinoda, and I head operations and business development side of training and competency building at Phytec India. On behalf of the entire Phytec team, I would like to thank each one of you for taking time out of your busy schedules to be with us today. Before we begin, let me briefly introduce our organization. Of course, most of you know about Phytec, but still, I'm going to give you a brief introduction about our organization. Okay. See, Phytec is having 40 years of excellence in embedded technologies and with a global presence across 5 countries, Germany, India, the USA, France, and China, and thousands of successful projects worldwide. See, as I told you, we are globally present, USA, France, Germany, India, and China. We are. And once if you come to the build for innovations, we help customers build innovative products using embedded technologies in areas such as Industry 4.0, manufacturing, data analytics, data mining, and includes the data analytics as well as. Then comes, this is our product spectrum. Our product portfolio ranges from system on modules and single board computers to complete OEM devices and customized solutions, helping customers reduce development time and cost. And once if you come to that technology and product portfolio, we provide both hardware and software solutions, including Linux, Android, cloud integration, machine learning, and long life embedded platforms. In fact, we specializes in ARM-based system on module, computer on modules, single board computers, and complete product engineering services, including hardware design, embedded software development, and manufacturing services. This is our product spectrum. Then once if you come to the customer service, see, we can't tell that the same rule applies for every customer. So that's why every customer requirement is unique. That's why we offer complete customization services from hardware and software design to product development and branding, in fact. And once you come to the manufacturing excellency, our manufacturing facilities are designed for both small and high volume production, ensuring high quality reliability and long-term product support. So based on the client, we take it up. This is. So what I mean to say is, Phytec is taking up end-to-end services. See, we are the single source partner for the entire embedded product lifecycle. That is from design and development to manufacturing, logistics, and long-term maintenance. Okay, so usually the customers may ask that why Phytec? Phytec because for more than 4 decades, Phytec products have powered thousands of innovative solutions across industries, serving customers around the world. So if you take up the products, we are into products, design, manufacturing, logistics, we are everywhere. That means if any one customer comes into our account, looking for any solution, right from design to the development, we are there both in hardware as well as the software side. And as I told you, we have a global presence in the customer base. Once if you come to the industry verticals, we serve multiple industries and bring our embedded expertise to diverse market segments and applications. See, for example, we are into Industry 4.0, e-mobility, transportation, medical and healthcare, energy, smart agriculture, building automation, and come to the health division. We are there everywhere. You name it, we are there everywhere. So again, see, these are all the broad spectrum of industry verticals. So each industry, if you take up, we are there again. For example, if you take up e-mobility and transportation, we are there EV charger, then vehicle diagnostics, vehicle management, everywhere we are there. And again, medical applications, our embedded platforms are used in critical healthcare applications such as patient monitoring systems, ventilators, ECG, and ECG machines also. Then once if you come to these are all the medical applications. Then come to the commercial applications again. You take it up, any commercial applications, we are there. Okay. Then we are into the global presence and we are what I mean to say, we are at the global present. And just before starting this, I want to introduce most of you know about Vasu sir, but I'm going to hand over to the Vasu sir. Sir, please, for you.
Thank you. Thank you, Vinoda ma'am.
Thank you, sir.
So warm welcome to Edge AI workshop. And thanks for pulling out your time. As I think many of us, many of you would know Phytec and myself, but just before jumping into the sessions, let me quickly introduce myself as an engineer, followed by entrepreneur. So myself, Vasu, and I'm a software coder since my schooling, fifth standard. So 1993 is when I started my software coding. And one of my remarkable project is basically birth certificates and death certificates, basically for Gajuaka municipality in 2001, using VB and then Oracle database, basically. I am a BSc Electronics and Computers graduate, followed by MSc Electronics. So I work for Wipro through Wipro to Nokia and Qualcomm, mostly on the semiconductor, Nokia for NMS and Qualcomm for semiconductor side, followed by LG Electronics. So again, I was part of a SoC development for smart TVs, where ARM Cortex 8 core based SoCs, smart TV SoC we developed during 2008. So then I merged my first startup to start Phytec India. So Phytec as a global company, as Vinoda ma'am was already introduced. So so where we merged our 5 people team, and today we are 75 plus teams serving more than 300 active customers in India alone. And then there are and then we mainly support the customers. We come in chip company, between a chip company and a product company, right? So since Edge AI, since last 1 year, we have been trying to bring in this workshop, which has been awaiting, basically. So we at our side also now, more than 1.5 year, 2 years, we have invested on Edge AI developments, and all couple of applications has been developed. So the idea is to share the knowledge, and then some of the industry practices, the things happening. So I thought let me give you the four pillars what we are trying to do. So first we thought let's understand the Edge AI from our opening session, and then the second one is how can we select appropriate hardware for implementing your Edge AI, because you are moving the AI to your low power hardware, right? So that's how it is becoming a edge. And then once you select this, so many times you are developing a AI application, but you should also know the software stacks beneath it, basically. So that's how we thought, like, also we will share a little bit of our Yocto experiences and customizing. So I'm personally building the Linux from a 2 MB flash and then 4 MB RAM since 2005. So it has been 21 years. We have been playing around with the Linux kernel, BSP and all, and then like you take any uh, custom hardware, how to fit the Linux into it is what is our expertise, right? Like, so that's, then we thought like, why not we share our expertise, which might be helpful for you when you are using edge hardwares, because each edge hardware comes in a different form, right? So I would like participants to use the chat to be active. So please write some examples of edge devices. So for example, your camera could be edge devices, right? So each of the cameras. So now in India, at least that deployments have been started. So one of the very important project, we have been supporting multiple customers in railway. So now they are started because most of the railways need cameras on the coaches, and they have started deploying these cameras. So today the AI is integrated as a boxes, but uh, along with some 4 cameras or 8 cameras in each bogie. But like there could be there would be a next variant or the next sessions where like the camera itself is AI, right? So where you are running AI models on the camera itself. So camera is one edge device. So similar to that, like please type on couple of edge devices in your chat box, just to be with the session, right? So that's how we thought, like, since we would be dealing with a customized hardware, so let's share the software beneath your AI stack and application, right? So that's how the second point was. And the third was the most important, is when you are developing a AI application, essentially you are not writing whole of your AI code, right? So you are just developing an application using existing model, or yes, in next phases. So we would be developing a custom AI models, and then are doing a micro models very specific to the hardware. We will speak about those things basically. So that's how we thought, like, let's be discuss a little bit on the stacks, open source stacks, which should be the first point. So this is more like, this session is more like a triggering point or a start point for the embedded developers to uh, we have been using a chat GPT and other AI tools, but like how we implement AI in our embedded space is that's what the starting point we thought basically. And our team, as I told, since more than 1.5 year, we have been investing heavily. We have a dedicated AI team of 5 people in India alone, where we are built a lot of use cases. So we thought of like quickly run through it, and then yes, we go for some interactions. That's how the flow would be. Right. So now I think we got a very interesting uh, inputs from the audience. So when we started defining Edge AI, right? So now many definitions, I think I read out many of them basically. Yeah. So CCTV, traffic control, washing machine, Alexa, automatic number plate reading, smartwatch, health band. So please please put all the devices. So when we say devices, devices more from a user perspective. So so let's put more of a user side or a industrial device side stuff. Some of us, we have put ESP32 or IMX18 plus. Yes, these are the hardwares, but like let's try to put more of um, um, a user devices, right? Like, so So the why we are shifting. So we 6 years back on a Phytec board meeting, we started thinking what would be the Phytec future, right? So now most of the things would be having on the cloud and all those things. So how Phytec would really see its future on the hardware space. Okay, so then we started drawing some system architectures. So where we thought whatever the IoT levels grows up, but there would be challenges on the connectivity. And then when we start moving all our intelligence to the cloud, and then if there are connection interrupts or the data transmission interrupts, basically, right? So your connectivity through your like a LAN or a Wi-Fi or a fiber optics or a star satellite communication. So whatever the level of communication technologies grow, but there will be always an uncertainty of the bandwidth on the communication thing, right? The reliability of the communication. And the third one is how much you want to push it. So how much even though whatever the communication channels, how much data you really want to push it to the cloud to make a reliable decision. So there were then we draw on saying that, like, yes, there will be still a cloud layer exist, or an internet layer exist, but like there are like edge computing devices, basically, so which will be a kind of a more of a mini AI servers or a cloud servers. And then the next level is your smart sensor or AI sensors. So now companies are also looking at, like, now how can I do today you have a tire pressure monitoring system within your each tire, right? So now when I am analyzing this pressure, and when I'm analyzing this, can it also turn to be a tire health? Today we are only talking about tire pressure, but like, can we also derive a tire health as we are deriving from our heart rate, our health, uh, health battery, and then health scenarios, derived lot of algorithms on your app side, right? But like from your body, you are only transmitting the heart rates, right? So these are the things which popped up. To and there will be these architecture layers. So not everywhere, but like many of them will follow the same architecture layers. So where the power would be one of the key factor, and the sensor layer will have these intelligence and all. And then there will be a next level of intelligence on the gateway devices, and the third most level of intelligence would be on the cloud. So not boycotting cloud or like leaving the cloud, but like offloading some of the major things related to latency and bandwidth and data. So, and then like offline, right? So these are the key words which you would see that, like, you want to delegate some of your intelligence to the device level, right? So, and as I told, like, when we coming from the custom hardware, so again the custom hardware need a custom operating system, which is more, and then like not only operating system but all the devices connected to it. And then finally lot of open source AI stacks or a proprietary AI stack. So what are these, how to deal with these things to solve these problem, right? So so then, from an engineering perspective, what we thought, let's share our experience, what we have been doing since last 2 3 years. 2 3 years, we launched our first hardware IMX18 Plus with two tops, and then my engineers started playing with just in Nano and all, and then we also built a couple of custom hardwares for NVIDIA Jetson modules, right? So then we thought, like, let's capture all those. And then so engineering first approach is what we thought, like, let's try to see, right? what we want to discuss is, let's discuss a little bit of fundamental things which will really enable you to take a decision of selecting a right hardware. And then from our perspective, we can give some of the examples from our side what we have been, and then like you can, on basis of that, like you can extend that selection, right? So for the very first thing, so a couple of my other videos on the embedded Linux and other things where we have. So I have deep down on the starting from architecture of the core itself, right? So x86 core or a ARM core, now RISC-V core. So the architectures, the processor architecture, the hardware architectures, basically. So, so we started with the processor architecture, and then like go to the SoC side, right? Like say what SoC to be selected. So whether we need to select a x86 processor or a ARM processor or a RISC-V processor on a very core architecture level, and then like uh, once that is there, then we move to a platform level, basically. So whether we want to select a module or whether we select a SBC, right? And coming to the AI, a dedicated AI, a dedicated AI. So uh, what AI accelerators are about. So let's try to decode these things. So from participants, can I get few of your inputs? What you guys have already been using as a AI accelerators, the AI accelerators, and then in market when you talk about these AI chips or AI accelerators, so you come up with lot of terminologies, right? So the first one is your processor, the CPU, that's fine. So without, so you can still, so AI is not something which we have been doing now. So if you really see decades and means 2 to 3 decades. So already there are like computer engineers who have been developing a lot of software algorithms which have been running on the system or the computer, and then doing all your computer vision applications and all, right? So AI, the computer vision things has not started today, right? Similarly, the data logging and analysis of your real-time sensor data analysis. So typically in industrial use cases, if you really see, you would see a lot of analog sensors which keep generating different types of sensors, whether it is a vibration or a temperature, the speed. So these all data has been also, since decades we have been processing those data. But at that time, so those computer software engineers, we have been developing a lot of algorithms taking this data and then processing them through our softwares. So at that time, so you essentially were using your processor, the pure soft processor on your hardware, right? And then most of the processing is done by this processor through the software algorithms, and many times they are running in sequential or like with very uh, minimal parallel processing. So the keyword here you have to tag it is the parallel processing, basically, right? So if you really know that, like Intel era, so there were hyper threads and threads, so cores and threads. So likewise, the parallel processing in your x86 hardware is developed to bring in more faster user experiences on your Windows operating system and other stuff, right? So then let's to be very specific on the AI part. So now you would be going through a lot of these terminologies: GPU, right? So graphic processing unit. So which is now mostly when we say AI, then we say you need a GPU hardware to AI, right? Okay, and then NPU, so neural processing unit, and then TPU, tensor processing unit, VPU, visual processing unit. So these are multiple terms which are representing your AI accelerators. So we have a different AI accelerators. Okay, let's decode those AI accelerators also. So I request participants to add couple of AI accelerators, part numbers, or like whatever the AI accelerators please push it on the chat. Okay, so the GPU term. So how the GPU term tossed to the AI? Because most of the very first AI applications we started demonstrating the capability of AI, we started demonstrating with images, with the graphics, right? Okay, so the GPU and VPU are the first two accelerators which were coined in the market. So the GPU, so the NVIDIA, how it become so big giant? Because not today, like I remember 20 years back we have been working with NVIDIA hardwares, and then we have been using a CUDA architecture of NVIDIA for parallel processing. Forget of the AI, but for parallel coding. So a lot of frameworks and software tools basically with for developing parallel processing basically has been developed, and then these were the early stage of our these AI. So where we started pushing parallel processing. So for example, so we write your for loop, and then if multiple independent data packets need to be processed, and then instead of putting on a for loop basically, so this threaded for loop, how can I create so that when I received number of data packets, so I can spin off multiple threads, right? Like so so likewise how it can be done. Okay, so deep hardware architecture wise, you if you have to go like within the processor, again there are multiple different terminologies like SIMs and so single instruction multiple data, multiple instruction multiple data. So there are multiple within the core, there are those other architectures are there, but the story of parallel processing started from here, and then that's how the CUDA architecture, which was a predominant push by NVIDIA. And then slowly that was their strength. And then they expanded it, as I told, the vision or a graphical accelerators, where first applications, it's not the all AI, but like today, if you really see, the most of the applications are related to this. So GPU, graphic processing unit, and VPU, visual processing unit. The examples of GPU, as you already know, the NVIDIA. VPU, Intel started its hardware accelerator called Myride chip, so which is again a visual processing unit, so where you play with all your images basically, right? So these hardware has been developed, and then a software ecosystem has been developed around it to not off to offload your CPU. So that's how your AI accelerators came into picture, right? So now again, this is more about the graphic stuffs basically, but like not everything needs a graphics. So now let's suppose I'm doing a predictive maintenance of my machine in a factory basically. So what are the inputs, right? So you get inputs from your vibration sensor, you get input from your the speed of a motor, and then you get a temperature of a motor. So these are the numbers to crunch, and you do sensor fusion. So you try to correlate the graph of speed to a graph of temperature, which need to be produced by your motor during at some point of speed, and then like you also see that like what would be the maximum threshold vibrations allowed, or like the motor is designed for when it rotates on x rpm, right? So now what you try to do, this maths is already engineered by the core engineer, the motor designer or the motor developer would have done all these analysis and brought down the design, right? So the motor, when it is designed, these all parameters and all the graphs are already there. So now if someone studies these graphs and then try to do the best studies basically, and the maybe by a user's from a user perspective, what we do, we're not going the deep down study, but like what we do is we try to create some or simulate some defective uh, scenarios, or some good and bad scenarios, and then we try to label and annotate the things, okay, and then we start calling it as an anomaly detection, right? So but like again coming back, you have to crunch the numbers, not always the images. So the AI, let's consider two things. One, processing the images, yes, where there is more number of pixels, more numbers. There is end of the image processing also, you are crunching numbers, but there are a lot of pre-processing happening over there. And then the maths over there is little bit different, right? So it's something like a matrix multiplication or kind of stuff, right? And then there is another thing where your accelerometer data, which is coming from your, like say, FFT. So any accelerometer data, you cannot process it directly. You have to apply FFT, okay, for your fast Fourier transformation, and then like build the peaks, build the patterns, and then do start analysis, right? So now you have the number crunching things, so which now typically you have your NPU and TPU, right? So neural processing unit, and then tensor processing units. So likewise, you have multiple devices. So AI, when you say AI have a different application, different use cases, different algorithms. So as per your algorithm, you have to choose one of these devices. So CPU, GPU, NPU, TPU, VPU. So these are different hardwares which will you have to select depending on what kind of algorithms or what kind of process is happening. So and one of and when we want to select basically, so you have to see that like in a AI application, what portion. So when you if you are writing an application, if you are writing a software, right, like let's suppose to perform a AI operation, you have developed a four major pipelines or functions basically, and now these pipelines, now you have to see which hardware is required and what kind of algorithm, what kind of data processing need to happen, and then try to select uh, whether it is a GPU or a NPU or a VPU or a TPU kind of stuff, and then share it accordingly so that like you get 100% of your data. We will also see that like how you want to how you gonna share that, okay, so no need to worry. But there are standard frameworks which can split these things and then run efficiently, right? So the idea is for an embedded engineer, if you really ask 1 KB, when I was writing my first embedded program, right? Every time I write C, that like each line or each function of my C code will produce how many opcodes opcodes for my binary, right? End of the day, how much memory I have in my microcontroller, and then how do I write it in an efficient way, right? So similarly, now instead of one microcontroller, you have many microcontrollers or many processor within your chip. Within your single chip, you have multiple processors now. Now you have to see that like how you can best use these processors available in your chip, and then do develop a application, AI application to utilize most of its power, right? So now, but like how do I while selecting, how do I select these, or what are the parameters, right? So these are few terminologies which you should know. Likewise, when we select any processor in a deeper down. So as a user, normally you say these many megahertz, right? Single core, dual core, 1 gigahertz, 2 gigahertz, 3 gigahertz, 2.5 gigahertz. So anywhere between 2 to 3 gigahertz is the x86 processor, or a traditional processors basically is Lion, and the embedded processors, high-end processors are within a 1 gigahertz to 2 gigahertz is the embedded processor stuff basically. And then going below a little bit more low power controllers, if you really see, it will be kind of like few tens to microcontroller will be in tens of megahertz basically. But now we have a latest architectures like ARM Cortex A7 and all, where you would see microcontrollers of 500 megahertz, 700 megahertz and all. But like typically when we take a very small low power microcontroller, typically they are in 1 to 100 megahertz. And then 100 to 1000 megahertz is the low power MPUs. And then from 1 gigahertz to 2 gigahertz is your high end MPUs. MCU, microcontroller units, MPU, microprocessor units. So ARM Cortex M series comes under your microcontroller. ARM Cortex A series comes under your microprocessor, right? So now for this, we typically we go with either a frequency, and along with it frequency to tie up with the software, we call it as a MIPS, right? Million instruction per seconds. So how efficiently my software can be executed on a particular processor and generate the output. So that where like we use the terminologies called MIPS and DMIPS, right? So now with these MIPS, so similar to the processor, now we see on a AI, basically AI accelerators when you are doing, so you are trying to use these parameters, right? These units, tops, G flops, basically T flops. So these are the terminologies you need to understand. And then when you are buying a AI accelerator, you try to see this. Okay. Apart from this, you need to know one more keyword, which is your token. Right now, whenever you are saying AI model, so this AI model is how big it is or how efficient it is, right? So now how much knowledge it has. So then you start measuring it with the data which it is already trained with. So typically in your Gen AI, like you come with these things, right? So tops, G flops, right? And then tokens for your model, not for the hardware, basically. Yeah. So one of the thing which we have to make note is int 8, right? So this is the when we are doing multiplication or any mathematical operations, basically. So you need to know the size of your word. So whether it is a 1 byte or 2 bytes or 4 bytes, right? So typically this is the size of your data chunks, the lowest data chunks which will be processed. And then for your floating points, FP32 and FP16. So right. So now when you are having a more complex data, so these are the uh, these are the units which you will be using. So why these are important? Again, when you are developing a model, when you are migrating the model from a x86 PC to a embedded hardware, and then like you want to optimize to make it more performance oriented, so you will try to crunch the data and then make sure that like with less data, how can you run your software or run your operation more efficiently, basically. So after once we understood these, so now the last challenge is basically is now these all things are okay. I will select a hardware. I will go to a online and search for some AI hardwares and then start doing the things. But like again, the question comes, what should we go with, right? Okay, so the last is basically what should I buy from a market? So whether I should buy a chip AI accelerator or AI accelerator module or a compute module, or I buy a complete SBC, right? So depending on what product you are developing, what solution you are developing, the nature of your business, you have to take a call that like whether you should start doing your R&D of AI development starting with a chip or a module or a single board computer, right? So a couple of examples of AI chips, as you know, right? Like AI accelerators. So in market, like now you would see a lot of startups has started developing AI chips, but like the starting era of AI chips started with Google TPU and Intel Myrad VPU basically. So you will find these are the dedicated AI chips, so typically in a range of two tops to four tops, and then you cascade many of these chips to make your embedded specific. I'm talking about these all are embedded specific. So we are threading little bit from the generic server side AI to embedded side AI. So that's why I'm whenever we are talking about some chips and these things, so it is more focused towards our edge or embedded side, right? So to make note on the chip sides, so you have Intel Intel Myrad VPU and Google TPU, right? So and then like we have now Helio AI accelerator, which is more from a Europe market, like it is very much famous and we have integrated into our modules. And then you have now NXP has acquired a company called Kinara. And then recently I know that like we have helped 5 years back one of the India first AI chip company Alpha IC, somehow they have sold, I think they have sold to different company. But like 2001 we were proud to say that like first one AI chip bring up we have done at Phytec India in 2001 2002. So there are these all are AI accelerator chips which will be essentially connecting to the microprocessor through USB, or typically PCI should be the best interface, or like in worst case the memory interface. So the memory interface is the fastest one, the second one is your PCI, and the third one is your USB. So these are the typical three interfaces using which a AI accelerator chip is connected to your host processor. So you would have a main processor and then you have a accelerator chip to run your or to offload your AI model. So many times you need to see that like when, so now for example you are developing products which are sold around 1,000 units a year basically, then like if you start your R&D or development with a chip, so by the time you develop your board it will take 2 years. So now whether we are right to time to market is what a decision you have to make, right? And then if you have a very niche couple of niche kind of product you are developing which will be sold around hundreds and 500s, not more than 1,000 a year basically, then you need to see that like whether I really also want to go for a hardware custom hardware design or not. So I'm talking about a chip or a module or a single board computer, right? So what should I select out from it? So for that you need to first make note of your application, what kind of application you are developing, how much it will be produced in your mass production time, or whether it is a simple solution, AI solution for a specific uh, automation requirement where you hardly need a 5 or 10 devices, right? So now those kind of very low volumes you select SBC, and anywhere 1,000 to 10,000 or 1,000 to 50,000. So 10,000 is a benchmark. So but like anywhere between 1,000 to 10,000, if you are really saying now again whether I should make a flat design or a module based design, again, depending on your application, how niche it is, how specific it is, then you have to decide and fall back on a module. And then if it is something which is very high volumes, then like you go with a chip down design. So this is what a selection you have to, or make a decision while selecting the hardware, right? So hopefully we tossed a couple of keywords. The very first thing is what kind of AI accelerators things, and then like which will be, how they are different, right? How GPU is different than VPU, then TPU and NPU, right? So GPU and VPU more from a visual perspective or a image processing, and then NPU and TPU from a more number crunching way. And end of the day, AI, what you are doing, AI want to do a lot of data processing, and then you need to achieve a parallel processing. So uh, there are deep dive sessions again, how to develop a AI processor or AI accelerator itself. So we can discuss on some of the other sessions. So I would be happy to to deep dive on those things, right? So but for you, the basic principle you have to understand is the parallel processing, how we can bring in the data processing or crunching mechanism within a hardware to get it done parallelly by a hardware is your AI accelerators basically. And these AI accelerators comes in market, but uh, a few of many of the applications. So camera, right? So AI camera really don't need hundreds of tops and all those things. So again, in this, when you are doing this, so you have to you have to uh, bifurcate basically couple of divisions. How should I how should I select these MCU or MPU? Many times the discussion is about like uh, how should I select these processor, microcontroller or a microprocessor or AI accelerator, but AI accelerator with what tops? So normally less than one tops. So typically I got few of the participants questionnaires basically while when they are registering. So arc detection in a motor or during a BMS basically. So uh, so when there is a very small sensor which need to be fitted into your device, and then you need to do processing basically. So you have a very specific algorithm which can run into your microcontroller, and that's how you thread that algorithm for a small hardware block which is available into your microcontroller itself. So when you move to TI or NXP or ST Microelectronics, so there now they offer many microcontrollers for these specific. So here you need not to do a very big high funder. So the best part is basically these companies have given already a very established tools where you have to just pull out some of their pre-existing models and start capturing and training the data to that model within the IDE. So you go to a typically any microcontroller, TI or NXP or microchip. So you go to any microcontrollers. So there you will find they have been or Renaissance. So they would provide you a complete IDE, integrated development environment for AI with AI functionality. So where you need not to really do much, but what you have to do is connect the hardware, start generating the real-time data, and then start annotating the data or start classifying the data, good or bad or multiple categories. And then finally the IDE will give a specific model basically which you can flash it to the MCU and then do the inferencing, right? So the typical design phases, what you have is basically first is your AI model development, AI model training, and then C, then inferencing, and then the final processing, or like normally we call it as a post processing from your application side. This is more of a app side, right? Okay, when the detection happens, so you want to do something. So typically here, these two, AI development is already done. So you will get a model, existing model by these MCU guys within the things, and then you just have to train the model and annotate so that like now it becomes intelligent to identify the data, and then once you program, it will be running on these MCU, which we call inferencing, and then generate able to detect anomaly detection. So able to detect when any problem comes, and then you write some action when it is detected what you want to do. This you will live see in the demo. What my team will show you as a small demo we have done for a PCB defect manufacturing. Okay, so when you try to select the AI accelerator, many times what is the application and how much AI acceleration is what I need, right? So this is typically less than 1 TOPS. Most of the NPUs, it's not even 1 TOP. Basically, it will be few kiloops or G flops basically. So where these MCU should be able to do. So if you are a very core embedded engineer and you are doing at a microcontroller level and you want to put a AI in your fan, AI in your motor, AI in your vehicle brakes basically, right? So these are the small things which you will be training in this level. So the next is 1 to 2 TOPS. So this is a low power, edge devices basically, so where you can run most of the things. So today we started our PC or a Jetson Nano and all to start learning AI. That's why we normally talk about anything around 100 basically, but on a device really you don't need 100x. So you would be amazed to see what all applications we have developed within these 1 to 10 TOPS. So now how much AI capable is your mobile? So most of these mobiles are carrying these 1 to 10 TOPS basically. Now maybe like later on it will grow more. So typically now there are together within Qualcomm processors and all, there are processors with 50 TOPS and around 50 TOPS basically. But like these for embedded, for a low power devices, so we typically go with this 1 to 10 TOPS, which will be internally available in these SoCs. So this is a on chip, these are on chip SoCs basically. So which have AI accelerators within the processor. So you have the on chip AI accelerator around 1 to 10 TOPS with a very low power. You could see the PCB manufacturing defect analysis what we are doing. Hardly we are utilizing 1 TOP. Please make a note, 1 TOP AI acceleration we are utilizing, or bandwidth of the NPU we are using. The NPU, the running is in IMX 8M plus. So similar to this, you have a Qualcomm, you have a little bit higher one where you will get 20 TOPS, 40 TOPS and all. And then you have uh, other uh, external chips, as I told, AI accelerators, which will be connected to the host microcontrollers. So these are few SOMs which are already having a AI accelerators within within the chips, and then these are the SOMs. These are the using that chip we have developed a SOM. So we are as you know, Phytec is a uh, platinum partner for TI and NXP. So we develop the chips. So these are the chips. These are the SOM modules, and these are the single board computers available. So you can either you can select a chip, you can select a module which will come with your all your memories, PMIC, processor, RAM, flash, all those things. So you will get a 3 centimeter by 3 centimeter or 4 centimeter by 4 centimeter SOM module and ready to use. Or you directly buy a single board computer which comes along with SOM module. So that's the easy path to select, right? So we'll take a small 1 minute thing to just see where we are. If we have some questions, you can put it on. So maybe a couple of you, if you want to ask any questions, please raise your hand. Then maybe some 2 or 3 questions we can take. So far what we discussed is basically we discussed most of the terminologies, right? Okay. So AI on the edge, basically. So how much capacity do really need, and then whether you should always see that like the hardware should have 100 tops or something. It's not like that. For as I told, at a microcontroller level also you can do a very small AI models, and the advantage is the microcontroller companies, the semiconductor companies itself have given a lot of algorithms, and which you just only need to train with the data within their IDE. So that's a very entry level edge AI for a sensors. So when you want to put AI within the sensors or a small devices, tomorrow I'm brushing my teeth, the brush need to give a small indication basically. So what speed I need to run by analyzing the motor speed, and then like some data of my already the sensors which can sense the things within my mouth. And then like, so these are very small models which has been already done. So at least like when I'm pressing hard or moving the thing, so the brush can develop some indication, right? So at a very small low power devices at a sensor level, you can go with a MCU. Second is MPU. So the within the MPU, like you have an internal AI accelerators, which is typically 1 to 10 tops. So the best examples, as I shown, is basically IMX8M Plus from NXP, AM62A from TIAM68. So these goes into your all medical, industrial, and all. So we are talking about these very high reliable, right? Like, so first you have to differentiate x86 versus ARM, and then why ARM, right? Okay. So and then we have seen different types of NPU. So not all AI accelerators are same type. And then what hardware to select to develop your AI application, right? So this is what we have done. So does IMX 8M plus 5 board? Okay. So I will take up the queries later, but I just wanted to give you a small break before we switch to the next topic. Okay. So how now we have selected the hardware. So whether it is a chip or a module or a single board computer, basically, so you have selected a hardware. Now you have to make this hardware ready. So most of the time what happens, you get a ready hardware and then you get a BSP from the vendor. Like most of us, we would have started a AI with Jetson Nano, right? Or a Raspberry Pi, or with IMX 8M Plus, or with AM62A. You might have bought a single board computer, and then you got all the things basically, and then you started writing your application. Or if some libraries are missing, you have a pip or sudo apt to install your additional packages. And end of the day, you have to solve all the dependencies of your application, uh, below application and above your operating system. So but when you talk about operating system, you connect again when it comes to a edge AI, right? So within the edge AI, sometimes what happens, you directly connect multiple devices. So as of now, the best example would be your camera. That is as we discussed, visual related applications. So when you connect a camera, when you connect audio, all those things, so you need drivers. So these drivers are integrated within your operating system as a driver layer. So you have a custom Linux operating system for your hardware, right? So then on top of that, once all your peripherals you are able to access on a custom single board computer, basically, right? So we want to have now the software side. So on the below layer, you have the devices or the peripherals for which you have an operating system, and the operating system resolves the drivers. And many times we develop these customized drivers, right? So not all cameras are same. Within cameras, again, you want to develop multiple different functions and all, right? Okay, ISP and all different layers are there. So those things are part of these drivers. So within Linux kernel, how to customize these, how to optimize these layers, basically. Okay, and then you have middlewares. So now within these middlewares, all your frameworks, all your custom algorithms, which you are not building but you will be using, right? So those comes under middleware, right? Your PyTorch, your TensorFlow Lite frameworks, basically the runtimes, basically. So all these things comes under your middleware, and then finally you develop your application. Now on embedded side, so the initial first, I think what you guys would be developing is you might be using a Ubuntu or Debian Linux distributions to run this. But if you really see the embedded side, the biggest challenge for you is to bring down the cost, bring down the power, bring down the size. So when you want to do this customization, so you have to go with your custom Linux operating system. And to build this custom Linux operating system, we use this Yocto as a build system. So before Yocto, there used to be a build root. Before build root, we used to use multiple script-based tools to to build our custom Linux operating systems. But Yocto is now industry de facto build system, basically. So it's much more the build system. So but basic functionality is a build system plus a distribution where you can develop the packages and distribute it, and then you also package it as a single image and bring in the security and all those things. So those are the things which you will be able to achieve by customizing at a operating system level. I'm not talking about a AI level, but AI, consider AI as an application. So below AI application, you are doing a lot of things. And these, how do you control these SBOM, right? Software bill of material, how you are going to control. So typically, once you are at a little bit of mature stage of your product, you start looking onto your BSP side, right? And this BSP, we try to help you out, basically. And then we help you to give, or most of the companies gives you a basic BSP, and then on top of that, you customize it. basically. And then essentially Linux bootloader, kernel, root file system, and within this, all these layers of kernel drivers and middlewares, these are the things which will come and you will package with Yocto. So there are a couple of open sessions by us within YouTube. You can you search Phytec Yocto sessions, so you would get a little bit more layers. So the advantage of Yocto is a layered architectures, and then the lowest component you deal in Yocto is a recipe. That means one software package. One software package, you call it as a recipe, a collection of uh, recipes which give you a functionality like a GUI, like a IoT, like a AI. So you will have multiples of such software packages and you will put it in a layer, IoT layer, AI layer, graphic layer, security layer. So you will form different layers of your operating system, and then you can always customize them as per your product requirement, different product variant requirements, and then you can customize this. So this is what 100 plus engineers over Phytec India we do with every day, developing a custom board and developing a customized Linux operating system. And today we help that with for the AI, edge AI part. So if you really see a scenario of a scenario of your camera based AI application. So you would see that there is a camera sensor, then you have a ISP, image signal processing, and then like in these are the software stacks basically, and then there will be a ISP driver within the Linux kernel. Okay, and then your V4L2 or GStreamer would be the thing which will stream the data, and then it will be threaded to your NPU or VPU or GPU basically, and then finally the application. So these all, there will be a specific softwares. Today, when you take, you might be giving only some commands, and then you run your application. You might not be much focusing on those low level softwares, but when you grow big or when your product is becoming more critical, more production version, so you want to take control of other layers. So at that point of time this would be, but as a very beginner you might not worry much on that basically, right? So then coming to the software layers. So what are the software layers for your AI development? So as a beginner, as an embedded developer, now I want to build the software, right? So what all the different softwares I have to think of, right? So here I said 1 to 10, below 1 tops is a microcontroller, 1 to 10 tops is your MPUs most of the time, and then 10 to 100 tops MPU plus AI accelerator, or bigger like Qualcomm kind of processors which are giving these. So examples are, as I told, uh, Helio or ARA2. So these are hardwares which are already there on our website. I will share you the link. So few of these things which we already have an experience, that is what I'm listing. Other than that, like, so the low level, earlier to these, there are accelerators like Google TPU and Intel VPU. So, but these were like anywhere between 2 to 4 tops and all. But again, they are having a next variant. So those were earlier variants. And then when you go to the server side AI servers. on the cloud. Typically, those are in 100x. So this is how you can differentiate the AI hardwares, basically, right? So before I jump to the software stacks used in AI, let me quickly give these things, basically. So so if you really see how our AI started, basically, so you can say evaluation evolve. Evolution of AI, basically. So how AI has started, or the generations of AI. So we started, the very first AI started with the Gen AI, where like we have these LLMs which is trained with lot of data, social data, whatever available in our internet, right? So those has been, and then you got a Gen AI, and then the once the Gen AI was ready, we start commercializing, making the apps. So that's how agentic AI came. So where you are developing a lot of chatbots and all those things. So where you set a workflow so that this Gen AI would be able to give a user story specific to a problem statement, basically, right? And more followed with a workflow. So you have told, if a customer asks this, you tell this, like that. So you have a bots or agentic AIs, basically. But these agentic AIs normally act on the workflow and the data which you do provide, right? The third layer is autonomous AI, basically. So where the AI have started adding the intelligence, basically, to make a decision. Here the decision making was done on the inputs given by us, or specified by us specifically. But here you are not telling what to do. It's trying to automate that decision making by its thinking, right? So when you reach from home, from your office to home, and your robot basically is offering you a warm water. Every day it was giving you a cold water, but today he is giving a warm water. The instruction for him was to serve you a water as soon as you come to home, but on a specific day you got a warm water. Why? So the robot was able to take a decision by himself. It is raining outside, and then yesterday you have little bit of cough, and then like today when you come, it would be more easy for you when you take a warm water, right? So so the agents have started thinking for you. So that's how autonomous AI has started. And then finally, these are like not only running on a servers or on a big hardwares, but also slowly, today, since beginning, we have been talking the physical AI. So these are the different evaluation, or the steps where we started the AI, right? Okay, now coming to the software part. So what are the software layers, and then how it goes? So as we discuss these phases is more important to understand. Okay, so now if I want to develop a AI application, my team will run through application. I have to stop myself, otherwise I will be keep talking. Oh, it's already 12:40. Oh, sorry for that. Let me quickly. Okay, so AI, when you want to develop AI models, so as a beginner, let's not think of developing a model. So typically you will be taking a open source one, or a provided by a vendor, which is a fine-tuned one. So normally we will try to little bit fine-tune it, actually. Okay, so fine-tune the AI model, or configure the AI model, and then train the AI model, basically. So while doing this training, so you need the frameworks. So the very first thing is you will be developing AI application. So in order to develop AI application, what you need? You need two things, right? So you need two things. One is AI framework, and the second one is your AI model, right? So these are the two things you will be using. So AI models, so now right now you are using the chat GPT, you know, different models, or you are using Cloud, you are using Google, you know that different models are available, right? Similar to that, for embedded, you have models like YOLO, FaceNet, right? So these different types of models are available for embedded. Not only embedded, it is running on PC, but like more customized to embedded. And then to to run with this, so now these frameworks, so like your PyTorch, okay, and then like your TensorFlow. Likewise, you have multiple frameworks which will be used to deal with your AI model, to deal or to fine tune and train the AI model, and finally develop a binary out of it, which will be flashed into your hardware. Once it is flashed, inferencing is done, right? So means you are using the model at a runtime. Okay. So in order to make these little bit common, so you have something. So this TensorFlow Lite, PyTorch. So these are the stacks which are used as a frameworks. Don't confuse. So this is from an embedded perspective. If you see, think like it is a tool chain, right? Now these tool chains, you need some libraries and compilers and all to build your binary, right, out of your source code. Similar to that, you want to build your model. Now when you want to flash this model in a different hardware, again there is a whether it will work for. So for that you have something called ONNX, basically, okay, Open Neural Network Exchange. So wherein which, similar to your Java story, if you really see in 2000, year 2000, you have uh, we were developing a lot of application, but like these applications runs on some hardware and it runs on different hardware. So like the mobile era has started at that time. So now you wanted to make something hardware independent. That's how the Java came, other than C or C++. Okay, we call it as a platform independent. How it was made? By bytecode. Okay, and these bytecodes runs using on a different hardware. How? In between hardware and this bytecode, you have a runtime, which is basically your JVM, Java Virtual Machine, which is a runtime, right? So the bytecode again is converted to a machine dependent, basically. And then we started it as a hardware independent. So the runtime, this ONX runtime will give you to make the models which are developed in different frameworks, okay, so that it is ported into a common format. This is a format exchange, basically, so that any hardware can run your model. So for that you need a runtime. So the tensor, each of the hardware will have these hardware porting, again driver layer and the upper layer, right? So upper layer is more of a data format, lower layer is your driver hardware layer, basically. So this ONX runtime, you can consider it as a JVM or a virtual machine, which will understand the hardware side, and which will understand on the top side, it will understand the application side. So these models, any model need to be transformed into ONX so that like it can run using some runtime, and this runtime will take care of offloading. Again in this runtime, so it will take care ONX runtime, it will take care what to offload to GPU, what to offload to TPU, what to offload to CPU, right? So currently your processor have all these things. Your processor have a CPU, your processor have a GPU, your processor have a NPU or TPU. Now within your application, AI application, there will be multiple functions which are fine tuned for these things. At the end, they will fall back to CPU if it is not supported. For example, on your web browser, you enable the GPU, but some format, if it is not not supporting by the hardware GPU, then you will download a plugin, right, for that running that software. So it is run by CPU then in a software mode. So similar way, your AI application, first it will try to use the best optimized hardware, then it will keep falling down. So whether I want to use a TPU or NPU, or whether I used to use GPU, or if it is not supported, end of the day, CPU will take care with software. So software codec versus hardware codec, like in multimedia domain, right? So these are the different software layers basically which we need to do. So here there will be a different models. So these are the models, prime models, like these are the real algorithms, and these are the tool chains basically, right? Resonate and all. Okay. So different vendors again give their uh, tools. So we will run through few of them. Okay. I will try to crunch in. So as you always know, like I'm little bit keep on things. So next time I will try to make little bit more streamlined. But I believe we were able to high level. We were able to understand why at JI. While selecting the hardware, you know all these terminologies, TPUs, VPUs, NPUs, and then how to what measurement units you want to follow, and why do you need a custom operating system to have the best edge AI. Okay, so it's not only Ubuntu or bigger open standards. You are developing a very customized hardware, so you need a custom Linux operating system. And then how we build a custom operating system using Yocto, different layers, Yocto layers and Yocto recipes. So these are the keywords. Please make note. Sometimes afterwards you can go deep dives. There are a lot of my sessions available on YouTube on each of these topics. And then we explored a couple of open source stacks like your PyTorch, TensorFlow Lite, and all those. These are the stacks. And then my team will give you some example of the models which we have used on our edge hardwares basically. And then let's jump to a quick demo. And meanwhile, you can put couple of questions which I can start answering. So others, Bhupati, Natarajan sir.
Yes, sir.
So we can randomly pick a few questions and then answer them basically. So most of them we are trying to reply.
Okay.
So Rajshekhar ji, a very interesting question. What is the motive of Phytec organization? So we are the OEMs. We have been as you know, like we are a 40 years old hardware company, OEM company. So we have been a pioneer in the control systems, and then the Edge AI is the current version of control systems. So where like we see that like we can help product making companies and accelerate their edge AI development to bring the innovative products. So that would be our motto, to help partners to bring their products quick to the market. So that's why we provide hardware, but around the hardware we do also provide a lot of engineering services around it. So more of a business questions I can take up, but others and Bhupati and Natarajan sir, you start looking on some of the technical things.
Okay, sir. Yes.
One after the another, we can take whoever on the lane.
Okay, sir.
From the chat we can take up. So what is what is the typical power consumption? So whatever the demo you have seen, so the power consumption is between 3 to 5 watts, 3 to 5 watts, whatever current demo you have seen. So our most of the Linux, embedded Linux hardwares take around anywhere between 1 watt to 3 watts of power. It is very much optimized, and the whole of the system. So what the demo you have seen, whole of the systems take anywhere between 3 to 5 watts of power. So Puneji give example of NPU, as I told, like so many of whatever these on-chip AI co-processors are there, those are the examples of NPUs. As we are the learners, we try to share very basic things to mobilize embedded developers. Hope it is helpful. And next level, Vinodha ma'am, you want to take, if people want next level of support for the training and other things, basically. So we have a dedicated program for the developers, as we were teaching all our embedded Linux and other knowledge uh, through the specific training modules. So we have dedicated training modules we are building for AI. So there will be multiple, but like to quick start whatever you have seen as a PCB manufacturing, that is one. But like we have built couple of digital factory use cases. We have built a lot of for a couple of automotive customers, automotive, the image processing, some of the applications. We have done automation like ANR and all such kind of things we have done. So there are a lot of references available. The advantage is today we have 10 plus applications already there as a references, and we can help you guys to develop such kind of applications and modify as per your requirement.
Okay, so it is a 6-week program where in the 4-week we will be giving an introduction to how to train the module, and then the thing is, okay, the first thing what we were trying to do is with the giving you the fundamentals of AI and the edge AI fundamentals, and then the second we will try to run through our PyBoard Pollux hardware architecture, and what are its I mean the ARM, what are its NPU and GPUs and CPUs and its memory architecture, cache concepts that we will be running in the week. Okay, so then in the second week we will try to go and use our the pre-trained model inference, and we will try to get the pre-trained models, and we will be putting in our NPU acceleration, and with YOLO we will try to go and fine tune. Okay, so we will try to run our pre-trained modules, and then the TensorFlow Lite we will try to convert that the pre-trained model to our board supported model, and then with that we will try to go and give an idea of how that CPU, GPU, CPU can be compared, and what is that float 32, float 16 and int 18, such kind of things we will be able to cover in the second week. And in the third week, it is something related to the custom data set. We will try to those and all which happened with the pre-trained with the general data set. Now we will go and move into our custom data set, and then with the custom data set and with the custom YOLO model deployment we will be doing in our board. And in the fourth week we will go with the edge AI application development. Okay, so whatever the thing we have done with the previous week, we will go and make it one application, and with a good GUI development on the PyBoard Pollux. And the next 2 weeks we will be giving you an industry edge AI guided projects. So this is where the flow of the training program which blows. Okay, Vinodha ma'am, from this you want to take care of the next?
Yes. So thank you everyone for your active participation and valuable time today, and please do contact me for the training of this edge AI. Even we take up the corporate trainings also. So if your organization is looking for a couple of people and even for the project services, please do contact me. I'm sharing my contact number once again here. It's 974165 2770. Please do contact me for any even hardware services or project services plus training also.
So the idea, the idea of these training, 6 weeks training is basically whatever we learned in last 1.5 year and whatever the experience we have, we wanted to share with you by developing one of the application. So this page will be still developed. So we means we add a couple of use cases. So our team has developed many use cases, many solutions we have already developed. So we take one of the use case and go through. It will be a more of a technical deep dive, technical hands-on sessions, wherein which you will be able to develop one AI application end of these 6 weeks. So 4 weeks is more about training, and another 2 weeks is supporting you to develop one use case on specific hardware. So this is mainly a online session, but like people from Bangalore or around Bangalore, they can always come. So a couple of out of these four sessions, we will keep one weekend as a offline session, where we can meet each other. So you can the people in Bangalore and around Bangalore can also come and spend with us at our office HSR layout for 1 week. At least out of these four, 1 week will be offline, and the same thing will be available online. So not compulsory. So essentially, it's a online session with 2 weeks of project development. So it's a kind of not some theory. Take some hardware and try to implement at least one application out of this. So as my developers are doing, I will try to see that like how we can guide you. So I would be the kind of a high level instructor, plus other my engineers will be taking. So as you know, like I moved away a little bit more from the real coding, but like still I take care of the system level design and all those things. So we have a handful of engineers who are already working, and then they would be helping me to educate you what they are doing and how they are doing, and then able to establish at least one success story, one application. So any feedbacks, please share, and then we will terminate the session. Thank you for your patience. As usual, we normally push back a lot of things. So, but we will in next session we will try to optimize. Sorry for the delay, and thank you very much for your valuable time spending with us and bearing us.
I have 2 minutes of time to address few questions because these people are a lot of people requested to address
Yeah,
this. Yeah,
yeah.
I'll
So
just
most of
go with the same questions people are asking. Okay.
yeah. Can you ask?
Well,
Can you check what is the repeated question?
yeah, repeated questions are like more into the AI powered industrial automation. Okay. For quality inspection and predictive maintenance, how can Phytec help accelerate these solutions? Mainly for the industrial AI vision.
So industrial AI vision, as they saw, this is the one of the use case, but similar use cases, we have multiple use cases. Request for a demo, share the way we can help them is basically they can share the problem statement, and then the most suitable demo we will arrange with our technical team. It's not by our sales team. You will get connected to our technical team, and then we will discuss your problem plus approachable solution. So at least for the image processing and all, so you have a very good platform, whatever you have seen. So this is again available in multiple variants. So today we are proud to say that multiple drone companies and robotic companies have already used our platforms and integrated into their system. So it's already in the market. So this is one of the platform which is available, 5-week basically. So which is again comes with three different variants based on different platforms. So IMX 8M Plus and IMX 9.5, we have this SOM, and then along with this SOM, we built a very small 7 centimeter by 6 centimeter SBC, which we are calling it as a 5-week and ready to integrate into your AI cameras. So in these AI cameras, you have three different variants. One is the two tops variant, which is will be using a on chip. So current demo was based on this variant, out of which again we have used only one tops of bandwidth of a NPU. So you can assume that like how many other use cases we can develop without any external NPU itself. Within this two tops NPU itself, we have a lot of scenarios which we can address. Similar to that, like we have a for 20 tops, up to 20 tops. Basically, we support a Helio 8 as a AI accelerator. So it would look something like this. This will be AI accelerator chip, and this is a main processor. So and then we have Kinara from NXP ARA2, which will be supporting up to 40 tops. So these are the three variants of SBC is there, and apart from SBC, we have a lot of bigger expertise. The very big team is there to to help you on the software side. So at least in Phytec India, we have 50 plus engineers where we very closely understand the hardware and build the software around it, basically.
Okay. Shall I move to the next question, sir?
Yeah.
This is a very common question and interesting one. We merged with so many AI process and development platforms available today. How Phytec does help customers to choose right hardware, software, and development ecosystem for their specific application?
So this session was specifically to address this question itself. Now in this session, if you really see, there are four major questions basically. So why Edge AI, or what is Edge AI? And the second one is, how do you select the Edge AI hardwares, right? Like, so difference between GPU, NPU, TPU, VPU and all. So we try to share our knowledge and understand. We help our partner to understand from our knowledge what would really fit into their solution to solve the problem, basically. So different problems need different types of hardware and software, and that kind of knowledge sharing is what we do, rather just selling a solution, ready solution to you. So our engineering sits with you, and then like as you saw, like different platforms are there in the on the screen. You see these different platforms which are already part of like multiple industrial AI solutions already. So how do you differentiate this with the currently available other market solution is basically, so one thing is like Phytec comes when you need a industrial grade, industrial plus. When I say industrial plus, if you are developing any product for industrial automation, like all your manufacturing things, and then if you are developing something for transportation in railways or public transport like buses and all those things, so there which the hardware which you want to develop need to be a very reliable. At the same time, it need to be available for longer time. Right. So there where Phytec comes in. So and then, for example, these are the hardware which are going in your DC fast EV chargers also. So where you need more reliability for a longer time support and very customized one, Phytec comes as a value additional partner. Otherwise, if something which is serving your purpose from an open market, keep using it. But somewhere when you feel it is not working, it stops. So we are there. Phytec team, a big team in India is available to brainstorm with you, to work with you, basically. So these are the lot of our single board computers. Many of them supports AI, but very specific AI platforms. If you want to see, 5VIP is one of our latest development, where we wanted to give again a very small size, 6 centimeter by 7 centimeter with inbuilt and external NPUs. And then a big software development and team. So these are the major value additions we provide from Phytec. Srini.
Yes, sir. I think most of the questions are from different applications. Okay, but for everyone you gave answers actually. One more thing from the The customer is asking for M62X platform they are already using, want to migrate to an AI enabled with pin compatible SOM. How we can help you in this migration?
So we have a FPSC concept basically. So where we have provided our this is our latest development basically. So where we are providing a FPSC, this is a SOM without connectors. Now, when you have a SOM from other existing SOM and you want to map, hardly you need a small mapper board which will map the signals, and then it can be a SODIM or it can be connector based and all. So very much there is a flexibility for kind of a lower and mid volume. For higher volume, again, we will try to give a customized solution. But for a quick answer to migrate from a MX6 to other things, so like we have these FPSC SOMs which they can explore. So we have a couple of dedicated sessions. So Srini, you can share those sessions with the specific partners who have asked.
Sure, sir. Yeah. Yeah, I think there are a lot of questions. Guys, sir is too keen like answering every question if I ask. But what I mean, definitely we will address each and every question in person. My team will connect with you, okay, to answer your queries, okay, help you in developing
So
the thing.
first, what we will do, we will take up every question and then you will get an email. And then followed by that, like we want to get more details from you to arrange a technical one-on-one interaction. So we are there.
Yes. So anything from your side, sir? I think we
Nothing.
can.
So any feedbacks they want to give us so to improve our next session? Yes, time is one. We are always in a urge of giving more. When I start speaking or teaching, I get into a sentimentals and then I go a little bit more extent. Normally, my people, my team try to control me, but I am out of control normally when I'm taking some sessions. So sorry for that, but like we will try to control that. Other than timings, just let us know any other feedbacks to improve these things, and similar workshops we can conduct you very specifically for your team, for your company. It will be a free session, mostly online, and then we can also arrange some demos very specifically to your team members within your company, and then that could be also specific to your problem statement.
Yes. Thank you, Vasu sir. Thank you everyone for this wonderful session. Okay, thanks for joining. And once again, I'm repeating, like, please share your valuable feedbacks where you can find that sheet in the chat, and also you will get that to your registered email address. Okay, and you can follow us on all our social media handlings, like where we attach that in the chat box. Okay, and once again, we will address all your queries in person. I mean, individually, my team will get back to you on that. Yeah. Thank you, everyone. Have a great day.
Thank you all.
Thank you all. Thank you, Vasu sir. Thank you all.